Hello, I am Ilya, and I want to present our paper, Scalar Function Topology Divergence, Comparing Topology of 3D Objects. It is a joint work with Darya Voronkova, Eduard Tulchinskii, Evgeny Burnaev, and Sergey Barannikov. We are going to study topology of sublevel sets of scalar functions. Given some threshold epsilon, this sublevel set can change and its topology also changes. And a persistence barcode precisely depicts the changes of its topology, for example, changes of connected components. How to compare topology of sublevel sets? On this slide, you can see two functions, f1 and f2. Each of them has three local minima, and this structure of sublevel sets is depicted by persistence barcodes. But the problem here is that two scalar functions are different. They have different local minima, but they are indistinguishable by their persistence barcodes, because persistence barcodes don't take into account the localization of topological feature. We are going to solve this problem with the topological tool, which we called F crossbar code. A frequent situation is a function having a domain in n-dimensional Euclidean space, and we assume that the function is approximated by its restriction on a sufficiently small grid. And to compare two functions having the common domain, we create the extended n+1 dimensional grid, or sometimes it is called a lattice. And values of vertex function in nodes of this extended grid is defined as follows, as you can see on this slide. By definition, F crossbar code of two scalar functions fg defined on vertices of an undirected graph G, or in particular case a lattice, is the case persistence barcode for a doubled graph or doubled lattice, and the lower star filtration induced by the function vertex function tilde f, which was defined on previous slide. To put it simply, each bar in the F crossbar code depicts the topological differences between sublevel sets of scalar functions f and g. It means that given topological feature exists in the minimum of f and g, but it does not exist in the in sublevel sets of f function. Scalar function topology divergence itself is defined as an integral numerical characteristics, which by definition equals the sum of lengths of bars in a F crossbar code taken to the p power. In the general case, F crossbar code can be defined for functions taking values of for an undirected graph. You can find more details in our paper. Well, how to compare topology of sublevel sets? In the example above, we can calculate F crossbar code for functions f1 and f2, and we see that it is non-empty. It has one bar, which depicts the difference in localization of one local minimum. Additionally, we have developed a visualization technique which maps bars in F crossbar code to the domain of functions under comparison. So beginning and ending of a bar highlights with points areas where this topological difference exists. The same could be applied for scalar functions defined in 3D space. For example, on this slide, functions f1 and f2 equal -1 in a vicinity of two concentric spheres and a bridge connecting them, which is depicted in green. In other areas of space, the scalar functions equal 0. We sample a cubical grid from the domain of functions f1 and f2 and calculate f cross bar code. You can see that f cross bar code is non-empty, and the visualization technique can precisely highlight regions where the topological difference exists. However, the regular persistence barcodes are indistinguishable for f1 and f2. As a practical application of the developed topological tools, we study reconstructing of 3D cell shapes from 2D microscopic images. We took a method which is called Shopper and replaced a topological loss inside it, which is based on Wasserstein distance, by the proposed scalar function topology divergence loss, which we made differentiable. You can see numerical results on this slide, and the Shopper enhanced with the SFTD regularizer is the best performing method by a set of quality metrics. You can find more details in our paper. Also, the proposed tools can be used for identifying topological errors in 3D segmentation. For example, here on this slide, you can see a 3D scans of brain, and the F crossbar code calculated for ground truth and prediction successfully highlighted region where a small void was predicted by mistake. To summarize, F crossbar code and scalar function topology divergence are topological tools which measure the dissimilarity of multi-scale topology between sublevel sets of two functions having a common domain. Functions can be defined on an undirected graph or Euclidean space of any dimensionality. Our tools outperform the standard approach, evaluating Wasserstein distance between persistence barcodes calculated independently for sublevel sets of scalar functions. The proposed tools provide useful visualizations of areas of topological dissimilarities. We develop an efficient scheme for SFTD differentiation. SFTD improved the reconstruction of cellular 3D shapes for 2D fluorescence microscopy images and identified topological errors in 3D segmentation. SFTD outperforms Betty matching loss in 2D segmentation problems. Our code is publicly available. Thank you for attention.